All right. All right, so let's do a couple of things. What we did last time is defining what derivative is. Derivative is this limit actually. So you in this kind of computations, you find this is the instantaneous velocity. It is you're talking about mechanics, physics, and if you're talking about a graph or geometric, so a graph of functions, this would be a called the slope of the tangent line. Okay, and in general, this is a instantaneous rate of change. Okay, without limit, this is what we call just the average rate of change. So with limit become instantaneous. And how the average relate to the instantaneous? Well, you just take the limit of the average as what you're taking averaging is getting smaller and smaller, goes to zero, and then you get the instantaneous rate of change. All right, so we compute this kind of, we did this kind of computations, given the functions, and find the derivative just using this limit. Okay. All right, so this kind of computation we did. All right, so let's do more kind of this kind of computations. So this is an equivalent definition of limit. So instead of using this kind of instead of this, we use also this one. Depending on the situations, sometimes this is easier, sometimes this one is easier. Okay. And let's do some problems related to this one. Let's do first some formula. Okay, we'll return to this kind of questions. Differentiability implies continuity. We passed this one. All right, so let's do this one, the rules for derivatives. Okay, there, whatever. Right. Right, so this is rules or derivative. Okay, so we have two differential functions, both f and g are differentiable, meaning that you have the f prime and g prime derivative. This exists. Then what you can do.
Sir, I think you haven't shared your screen.
Oh, share the screen yet. All right, sorry. Where is that thing? Zoom. Right, OneNote. Okay.
All right, thank you, sir.
Okay, so thank you for reminding me. You have two differentiable functions, and what can you do? First, you can add them together, okay? and then take derivative, and that amounts to take derivative first and then sum them up. Okay, that means you sum first, take derivative. It's the same as take derivative first and sum them up. Okay, so derivative and plus sign, that interchange. Same as the with subtract. Okay. Okay, and then second is that if you have a function f, take a multiple, right? Then you take derivative. It amounts to take the derivative of f first and then multiply by alpha. Okay. And but the thing is that what about multiplications? Okay. Now multiplications is a bit different because let's see, in the computation we okay, we know a couple of things, that f be 1 over x, that g is just x. So f times g is just one constant functions. Okay, so what we have here is that fg is the derivative of constant function, which is 0. On the other hand, we computed that earlier, not earlier today, but last week. Derivative of 1 over x is 1 over x squared. Okay. Remember the computations? 1 over x plus h minus 1. Okay, so before we compute the limit, just let's simplify this one first. So it is x plus h minus, sorry, it should be x minus x. Okay, so this cancels. So you have minus h divided by h, right? Okay, so as you take the limit, you just plug in the h goes to 0. Okay, so what you get is minus 1 over x squared. Okay, and g is just the easier 1. Okay, so if you multiply them out, what you get is just minus 1 over x squared. And the thing here is that they don't match. Okay, so what it tells you is that if you multiply first and take derivative, and then take derivative, and then multiply by the second derivative of the g, and that's not the same. Right. In fact, we have a kind of different rule for this one. Okay. And that is, let's do some computations a little bit. So let's fg Okay, these kind of computations. All right, so let's do some trick. This is like a pulling a rabbit out of a top hat, x plus h. So you subtract, say, f of x, g of x plus h, and then you add. So basically you add nothing because once you subtract and then you add them. Okay. And this is, okay, so 1 over h. Okay. So what we do here is that we factor, let's see, what's the same is a key of this is common factor. So what you have is 1 over h here. Take this out, g of x plus h. What's left is f of x. Same thing here. Uh, take the common factor. Common factor here is just f. So let's take this out. And what's left is just g. Okay. And you see what you have here is that here you have take multiply by, and then this one, and but you have this over h. All right. Can you recognize something from here? Can you recognize the terms here? What's special about this one? Why we write uh, stuff here as the sum, and especially this one here. Do you recognize this one?
Derivative.
Derivative. And when you take the limit, as same thing here. If you take derivative, sorry, take the limit, you get derivative. Okay, and when this one goes to 0, this is goes to g of x. Of course, this one remains the same. Remains the same. This is just x. Okay, so what it tells you is that this formula number 3, what we call a product rule, is that if you take a multiply first and then take derivative, what you get is that you apply the derivative to the first one times g, and then f times derivative of the second terms. Okay, so this is what you call a product rule. And if it doesn't work for a product like this, so you don't have any reason to believe it will hold for division. Okay, so this is what we call, sorry, it should be the, this is like the quotient rule, meaning if you take the quotient f over g, and suppose this is defined, that is g is not 0, then take derivative. What you have is this thing here. This one looks like product rule, but instead of plus, you have minus, defined by g squared. Okay. So example. All right, so let's take derivative of say 1 over x to the fifth. Okay. So let's take, this is our f, this is our g. Okay. So use quotient rule. What you have is derivative of the first one, just 0. And f times g, g prime, so derivative of g. So f is 1. And derivative of x to the fifth. Well, we derive the using binomial. We prove this one. That is for n from say from 1, 2, 3 integer. Okay. So this is just 5 x to the fourth. Okay. Square of power 5. So this is power 10. Okay. So what we have is that, so minus 5 is this x to the, say this negative 6. Okay, so it turns out that because x to the fifth is the same as x to the power of negative 5. Okay, so it turns out the rule that this formula here, it is still true for negative n. So you can extend this formula not only for n integers, but any, sorry, this is for natural numbers. So you can extend this formula to for integers. So it may involve a negative power, okay? And the rule is this is the same. So power 5 and power negative 5, you multiply by the power negative 5, and then reduce the power by 1. Okay. All right. Before we proceed, we'll use some notation, introduce notations. Um, if you see these notations here, this tells you that to take derivative with respect to x variable. Okay, so using this note, so it's the same as this one. So the derivative given a function f, derivative is f prime, or you can say the dx of f, and sometimes we write this as df dx. In a sense, this notations this makes sense in this in this way, in this sense here. So derivative means h. Okay, so this is delta f, so difference in f, while h is difference in x. Okay, so your notation of df dx is basically from delta f divided delta y, and you take the limit as delta x goes to 0. Okay, so what it tells you is that this d is the limit of this delta. So, okay, all right, so we'll use these notations. Okay, for a rational function. Okay, for example, we compute this one. Whenever it is defined, okay? All right, so this is quotient rule. This is our f, this is our g. Okay, so what you have is that derivative of f. So this becomes just 2x plus 7, because this is additions. So you just take derivative of each one and then take the factor out. Is the coefficient. Derivative of -1, that's 0. Multiply by this. Okay. And you subtract this f times derivative of this. Okay, so take derivative of each one. So 4x cubed minus 2, just multiply, so it's 4x. Yeah, that's it. And divides by okay. If the problem doesn't ask you to simplify, then that's it. You're done with this. Okay, no need to simplify. Okay. All right, we'll do this, some more example of this later. We just try to build up our library of derivatives. Okay. All right, some examples. Let me just stop share. I'll better share the screen though. Let me, so I can move around. What I would like to show you is this. Okay, so can you see this one? This is the for the next tutorial from this chapter. Okay. All right. So given this limit here, number 4. Okay. So express this. Basically, this is this problem tells you to compute this limit, but computing the limit by expressing this as derivative and compute derivative. Okay. Okay. So let's do this problem. Let's see. Can I do some copy paste here? I need to find it here. Let's see later. Okay. Problem D, for example. Let's leave it. Or B. It's not share, but let's move to sample 3. As derivative. Okay, so this one, limit of x goes to 9, square root of x minus 3 over x minus 9. Okay, so we would like to write this down as f prime of a. The question is, we need to find f and a. Okay, but recall that this limit here, there are two ways of computing derivative, and okay, if you use this one, then h goes to 0. If you use this one, then y goes to x, and that's give you the same thing. Okay, use this one. All right, so we're just guessing here what should be, or because we don't seem to see h and x goes to 9 also. So looks like it better fits this one, the second form. Okay, so if this is supposedly in second form, what should be the f and a? So let's rewrite this one first. This is the same as, let's change the variable. Nothing prevents you doing this. Oh, what happens? This one? why the green doesn't work, but red works. All right. Okay. Okay, so we stuck. Okay, let's restart OneNote. Okay. Can you see my OneNote?
Yes, sir.
All right. Good. So
Yes.
this is, all right. So you're just replacing X by Y. So nothing prevent you doing this one because what's called it variable. The name of the variable is just a dummy variables, right? So you can change to anything. All right. So this makes you clearer how to relate this and this one. Okay. So I guess you can guess directly here. Let's check. You make a guess. F of y equals to square root of y, right? Check. This should be f of, sorry, equals to 9. Okay, let's check. Well, this should be f of x. This x is x equals, let's see, 9. Right? Let's check. F of x is okay, so that's match. And right, so you get this one. Okay, so this is our so let's do this one now. It's actually f of 3, f prime of 3, sorry, f prime of 9. With f of x equals square root of x. Okay, so remember, function is a rule. So it does not depend on what letter you use for variable. Okay, so the rule is taking square root. Okay, so it doesn't matter you use y or x or whatever symbol that you use. Okay, and because the derivative of x squared is, let's see, we did this last time, right? So let's do this one. So you're quite fluent with this one. So okay. And you multiply because we would like to get rid of the square root. So we multiply this by its conjugate. Its conjugate means you have a sign, sorry, change sign to plus. You basically multiply by 1, so it doesn't change anything. And the thing here with this is a minus b times a plus b thing. So you get the square of the first one minus the square of the second one. Okay. And this cancels. Okay, so you get minus h over, oh, H cancel is this. Sorry. Okay. H cancel. So what you have is that do you have negative? No. It's H. Oh, H disappear. 1 over when you take limit square root of x, square root of x. So that's derivative. Okay, so what you have here is that this is 1 over, okay, 3, so this is 1, 6. All right. Okay, so the next problem, example, is this one. It's limit. Get stuck, okay? What happens to this one? So, okay, actually, doesn't take too much. Okay, however, okay, here it goes to 0. Okay, 5 over 3 plus h square minus 5 over 9 over h. When we would like to have, so need to find f and a. Okay. Now what we would like to have is this a definition here. Okay. So we would like to have this is the okay, and this would be, say this a, this is a. Okay, so that's we easily guess that f should be x as a rule. So 5 over let's see. Oh, okay, and a is 3. Okay, so you see that, sorry, f a plus 3 plus h should be 5. A plus a is 3. Should replace this by f of 3 plus h is 3 plus h squared. So that match. And f of 3 is that 5 over 3 squared is 5/9. Okay, so let's match up. All right. So then if you continue with this, equals to derivative of f. Okay, so take the 5 out, derivative 1 over x computed at x equals 3. This notation means we'll use these notations. Okay. All right, so let's see, this is derivative. Oh, sorry, x minus 2, because there's negative power. So the derivative multiplied by the power, so it becomes negative 10. Okay. And then for this, reduce the power by 1, so it becomes negative 3. And you plugged in x equals 3. Okay, so what you have is negative 10 over 3 cubed, right? So negative 10 over 3 is 27. There. Okay, so that's the limit. Okay, questions? If not, then we'll stop here for a break. Take a 5 minutes break. Okay, so let's